Hello everyone, today I'd like to introduce you to how to georeference maps in ArcMap. And I'm running ArcMap in Microsoft Remote Desktop from my Mac. And that means that I need to switch over to the window where I have Windows running. And here you'll see a couple of different things that I have open. So before you get started, please pause the video and make sure that you've got a blank ArcMap doc up and running, and that you've also got, if that's relevant, obviously, if you're doing this on a Windows machine, you don't need to worry about this, but get everything set up in Remote Desktop if you happen to be working from Mac. So what we're going to be doing is dealing with a series of 4 different maps from the Peruvian Geological Survey of an area called Chachapoyas in the northeastern portion of Peru. And I've downloaded these off the website in their complete format here. The first thing I want to do is actually take a close look at the maps and figure out what coordinate system they are found in. And so I'm going to zoom in here to my map in Adobe Photoshop or whatever photo viewer you happen to prefer, or photo editor you happen to prefer. And I'll see at the bottom information in Spanish about how the map was made and the coordinate system that it uses. Here you'll notice the location within Peru with longitude and latitude around the edges of this graticule. And here we can see Sistema de Cuadrícula Coordinate System, UTM, every 4 kilometers, zone 18. And then it says Geodesic System, World Geodesic System 1984, WGS 1984, Zone 18, and I happen to know that we're in the Southern Hemisphere, so this is 18 South. Perfect. So what we actually need to do from this point, and this is often what you'll need to do if you have ingested a map that is not already perfectly trimmed, is we actually want to clip it. So I'll zoom out a little bit so that I can see. I've done a poor job here. I need to make sure that I've got all of the reference information in there. But for GIS purposes, we really don't want that legend to be contained within the image. So I'm going to go ahead and clip this so that I can still see these tick marks all around the side of the map, essential information that we'll need for georeferencing it. And that looks more or less good. So I'll go and save this in the same folder with just an underscore clipped added after it. And I'll leave it in TIFF format and close Adobe Photoshop. You'll want to do this with each one of the different images that we georeference. Now let's go back to ArcMap, where we've got an open ArcMap, blank ArcMap document open. And in the lower right-hand corner here, you'll see that we're dealing in unknown units because we've yet to designate a coordinate system for this particular ArcMap document. We know what that is, though, and we need to begin, before we georeference the map, by designating the coordinate system in this data frame. I'd like to right-click on my data frame, which is called Layers, in the table of contents, and choose Properties, where I'm going to choose WGS 1984 UTM Zone 18S, as was specified on the map. If you don't already have this saved to your favorites, the way that you can find it is either by searching for it up here, which is a bit complicated, given the fact that you actually have to type it in exactly this way to find it, or by navigating through the file tree here. Under projected coordinate systems is where we'll find it, since this is a projected coordinate system. We've talked about those in lecture. Then UTM, then WGS 1984 Southern Hemisphere, and ultimately WJS 1984 UTM Zone 18 South. So let's click on Apply and OK. And here we'll notice that the units have changed to meters, but there's still quite a bit of confusion on, well, it's not confusion. We simply haven't told it what scale we're working at. So here we can see pretty much the entirety of the UTM scale. It's now our job to use the information contained within our map to place it in geographic space in this coordinate system. So I'm going to navigate to the file location where I have this map stored. I've clicked on Add Data up at the top of the screen, this plus sign that we always use for adding data. And I will locate the file that I've created called Chachapoyas 13H_clip and add that to the map. This is a new file, so ArcGIS is going to take just a second and create some pyramids to make it easier to show us. We'll get this unknown spatial reference error because the map does not contain any information about its geolocation. We need to add that. So it will be automatically projected on the screen where it's fit to the screen. And the scale that we're dealing with here really has nothing to do with the map itself. According to ArcGIS, default settings, the number of pixels has been used to decide how much space this covers, and it's estimating that this map, the geographic space mapped within this map, is only 22 meters wide and something like 22 meters tall. We know, though, that we're dealing with much larger areas, and we can see them represented here using the blue or cyan, sky blue colored lines found around the edges of the map. And what we want to do is find the intersections of these locations and use them to place this map in geographic space. It's a bit confusing if you've never done this before because UTM nomenclature or UTM conventions oftentimes take out the zeros. And what we're seeing here is actually a reference to the number 172,000 or 172,000 east. And here 176,000 east, because as the map told us, it marks space in UTM coordinates every 4 kilometers. Here, we're dealing with 9,332,000 or 9,332,000, and here's 9,336,000, which is probably the top of the map. But since I can't actually see that line, and I like to be dead sure that I know exactly what point I need to be georeferencing, I'm going to use the intersection between this line 172 and 9332. And in order to do georeferencing, I need to open up a toolbar that isn't normally docked in the ArcMap default settings. It's called georeferencing. Because I'm working in remote desktop, I want to dock the tool here at the top of the screen. And I want to make sure, particularly if I've got multiple files in my ArcMap document, that I have the correct map selected here in the georeferencing toolbar. It's not an issue because we've only got one map in our table of contents. But we definitely want to be sure of that. And what I want to do now is zoom into the intersection of these two lines here, which we remember are 172 east and 9332 north, and locate the middle of that intersection as best I can, which to me seems like it's more or less here. At this scale, the pixels are a bit difficult to make out, but I think we're more or less okay. Now I've clicked on the center of this in order to create a control point. And in this circumstance, because I'm not georeferencing one image to the next, I'm simply going to enter the coordinates by now right-clicking and selecting Input XY. Here, we want to enter the easting in X, which is 172,000, and the northing in Y, which is 9332,000. As we do that, the map will disappear because it's moved to a totally different coordinate space. In order to find that, we can just click on full extent, and ArcMap will take us to our location where we can see our beautiful control point, one of 4 that we're going to place on the map, located here in the upper left-hand corner. I'd next like to move to the upper right-hand corner to a scale where I can see the values of each UTM line, and here we're dealing with 220,000 east, and again 9,332,000 north. Once again, I will zoom in rather closely to the intersection between these two, and remember 220 east, 9332 north. This is a bit more difficult to make out, but I'm going to place the point right, let's see, right there, and type in 220,000, 9332000. You'll notice that the numbers were closer to where they needed to be this time because we started to provide some information about location, and the map hasn't zoomed away. It's simply been stretched out. So we need to place 2 more points in other corners. Here we're presuming that the scan is fairly good, but we're going to check the error when we're done with this and see if we need to add additional control points in order to improve our georeferencing. But for now, let's go down to the lower right-hand corner. Do the same thing again. Let's use 220 because it's easier to remember, and 9284 north. And it looks to me like this is actually the line that we want to be working with. So I'll place it as close as I can to the middle here. 220, and here the numbers are almost on the dot already, so let's just edit those that need to be improved. And this is 9284, 000. Remember that northings in UTM always have 1 additional digit. This is to help disambiguate them from the eastings. So you get 6 digits in the eastings and 7 digits before the 0 in the northings. And here we only see a minimal shift within actually the scale of our zoomed in window here, which is nice. It's exactly what we would expect. And then I'm going to navigate back out to the full extent of the map and go into our final corner where we'll place a reference point at 172 east and 9284 north. And again, I will grab my control point tool, place it as close to the intersection, center of the intersection as possible. And here we can just minimally change the values 172,000 east and 9284,000 north. Great. Now what you see here, now that we've placed 4 control points on the screen, is a graphic representation of the error. If we open up, actually let's go ahead and zoom out to the full extent of the map. At this point we want to see how good our georeferencing is and whether there are a large number of internal errors. We can do this by opening up View Link Table. In this table we can see all 4 of our control points along with the residuals, which describe the error in the fit between the map and the geographic space that we've attempted to accommodate it to. And the bottom of the screen here, or the bottom of the window, you can see the type of transformation, mathematical transformation we're using to try to fit the map to geographic space. Here we're just using a first order polynomial, and we can, if we've got additional points, use a second order or even a third order polynomial transformation in order to stretch the map in more complex ways to fit into geographic space. That's a bit beyond the scope of this week's lab, and we'll be handling that in the next one when we discuss georeferencing images to images. But suffice to say that this is a fairly good result. We're dealing with residuals of only 1.97 meters in a map that is rather large. Remember, each one of these different squares is 4 by 4 kilometers. So this is a good result. And for our purposes, which are to look at the relationship between geology and archaeological sites, I think this is good. I think that this is actually really within the range of accuracy that we can expect of the map itself. The map was not created using geophysical instrumentation that's going to show us differences on the order of sub-meter distinctions. So I'm perfectly happy with that. However, depending on the map and depending on the scan of the map, we may want to use a more complex geometric transformation. Okay, so there are a couple of different things we can do right now. One is we can update georeferencing, which will store the information about the position of this map in a file associated with the scanned map image. And we can also rectify it if we so desire. And if we rectify it, we're actually going to create a new file that is projected in geographic space. This is actually one of the best practices for doing this because we can specify how we want the values to be resampled when we convert from the ungeoreferenced to the georeferenced version of the map. That is, when you move one pixel value, and this is the sort of thing I actually would need to illustrate on the board, and will do so in my next lecture. When you shift a pixel value subtly in space, how do you translate the values from the unshifted image to the shifted image? And we're going to be using nearest neighbor in this particular instance. Actually, let's go ahead and use bilinear interpolation, which is actually better for continuous data. And we can specify differences in cell size and what the no data value are, as well as differences in compression here. Again, all this is a little bit beyond the scope of this current lab, but let's call this Cha-Cha Geology Rectified add. Nope, sorry, we just need to specify the folder here. So Cha-Cha Geology, and then generally favor fairly long file names because I like to know what the relationship is between them. So I'll just add rectified here. It's not ideal for some types of file exploring because you can't always see the entire file name, but I think it's a good practice because it enables you, when you go back to your data, however many months or years after you initially create it, you'll be able to suss out the relationship between different files. And we all like to think that we're going to be recording metadata about processing, but I think it's good to have a little bit of redundancy in file names in order to point to those processes and relationships. Anyway, so we can go ahead and update the georeferencing on this. That means that every time we open up this file in another ArcMap document, it will be placed in space more or less like this. And if we so desire, we can also open up the file that we've just created with the suffix rectified, and it will be more or less exactly the same. The color is stretched a little bit different, which is why you can see the difference between those two files. But either of these will be good for the purposes to which we want to put it, which is we'd like to trace out the different geological formations that we can see here and turn them into polygons so that we can perform some overlay analysis with the locations of archaeological sites. Anyway, that's just a quick description of how to do georeferencing, and I encourage you to be in touch with me if you have any questions. Thanks.